Hello, everyone. Thanks for joining us today. I'm John Noonan of Azure Marketing, and I'm excited to have Principal Program Manager Madhan Arumugam with us to discuss Linux and open source solutions in Azure. Before we get started, just want to direct your attention to a few of the widgets on your screen. We'd love your feedback, so please fill out the poll questions on your bottom left. Additionally, just want to note that a copy of today's slides can be found under the resource list. And lastly, if you have any questions along the way, please submit those via the Q&A chat widget, and we'll be sure to answer as many as we can at the end of the session. And with that, I'll hand it over to Madhan.
Thanks, John. Hello, everyone. My name is Madhan Arumugam. I am a program manager in Microsoft Azure, specifically in Azure Compute, and I lead a team of program managers focusing on making Linux and open source solutions work really well on Azure. And I'm excited here to kind of talk about what we have to offer. Regardless of whether you're using the cloud for development and test or running production workloads, or you are running workloads that are spanning on-premises and Azure. I hope you'll find the content useful. Before we start, obviously this is a large area. I focused on getting started content to optimize for folks who don't know about Azure or who don't know about Azure support for Linux and open source. Obviously, I will provide some links and best practices in the talk, but I'm looking forward to a deeper conversation, as we go through this particular topic. All right, so the first question I wanted to kind of address head on was why Azure? Why should you even choose Azure for your public cloud needs? In very simple ways, we think about the value proposition for public cloud to customers in three different ways. One is the ability to kind of create applications that are spanning, capacity that requires, resources, whether it's compute, memory, storage, networking, that spans beyond, your on-premises infrastructure. And that's what we call as hyperscale. The ability to kind of create applications that are really large, that can potentially span capacity that, even a single region can't, consume and provide. So public cloud is especially appealing to be able to use such large capacities at relatively less cost compared to on-premises. So, hyperscale is a very compelling value proposition for customers looking at public cloud, whether it's for development test purposes or for running production large-scale services. Enterprise grade is the notion of being able to have the same sort of service level agreements and quality of service agreements that you have with your IT infrastructure in public cloud as well. Just because you're using public cloud doesn't mean that your applications have to kind of live up with less SLA. So this is obviously a requirement for a lot of enterprises looking to take advantage of public cloud. And the last value proposition we think for public cloud is the notion of being able to use a public cloud infrastructure for running any workload, right? Most enterprises today, they have a mix of workloads, workloads that are developed a long time ago in a specific set of choice languages, .NET, Java, or any of the languages that you've used. But at the same time, they're also developing new applications on top of old applications. So, we want to be able to support all these applications and not discriminate one versus the other. We also appreciate that a lot of customers today have huge investments in their on-premises infrastructure, and they want to be able to continue to leverage them as they move into public cloud. So this is the notion of hybrid cloud, where customers at their own pace can make a decision on what they can use public cloud for, whether it's development test or production services. And they can even construct services that can actually span multiple clouds. This is the notion of the hybrid cloud. So from Azure as a cloud provider point of view, we think we are uniquely positioned to be able to support all three value propositions. Our competitors typically are able to satisfy one or two of them, but not all three. And we believe customers and enterprises looking for public cloud require all three. And we'd be interested in providing differentiated services on all three dimensions. Now, why Linux on Azure? So obviously Microsoft has a long history of supporting .NET. A lot of the innovations that came from the Microsoft stack applications, right? Whether it's SQL Server, Active Directory, SharePoint. With Azure, as a public cloud infrastructure, we obviously want to be able to run any customer workload customer wants to run on a public cloud, right? So, and that means we are, much more open than just saying .NET runs on Azure. So, .NET obviously runs on Azure, SQL Server runs on Azure, but we want to go beyond that. And the three dimensions that I talked about in the previous slide is continuous here. Any customer, any enterprises wanting to take advantage of the public cloud, regardless of whether they are running Linux or Windows as their base operating system, they have the same needs. They want to build large hyperscale services. They want enterprise grade, service level agreement and quality of service, and they want hybrid capabilities, right? So the requirements don't change because I'm an enterprise using Linux or I'm an enterprise using Windows. And the truth of the matter is, if you look at what has been going on in the current infrastructure in many enterprises, all enterprises use a mix of technologies, right? This slide attempts to kind of paint that. You're using either the Windows ecosystem with its Office products, or you're using the open ecosystem, with Node.js, Java, MySQL, SAP. You see some of the key popular, open source workloads, and typically enterprises have a mix of them. The percentage mix of Windows versus Linux workloads or open source workloads versus commercial workloads might be different, but the truth of the matter is, there's always this mix in any enterprises. So when you're thinking about choosing a public cloud provider, you want to make sure that you have the most open public cloud possible, so that you can actually host any of these workloads. So you don't get into a situation where you say, oh, I can only run MySQL-based workloads, for instance, or I can only run a .NET-based workload. So at Azure, we are fully committed to making sure that Azure is able to support any of the open workloads in addition to Microsoft's own workloads. And the history of our open source contributions, this is not something that we are doing just a year or a couple of years. We have over 10 years of open source involvement, all the way back to Windows installer that we released on open source force. That is still being used pretty actively. And you can see some of the points in time contributions that we have made all along, starting from 2005 when Bill Gates wrote his famous interoperability memo. Our CodePlex contributions, this is one of the open source repositories where we made thousands of contributions. The PHP contributions that we made. We also started our first Hadoop H-based contribution in 2009. In terms of our support for Linux-based workloads on Hyper-V, which is Microsoft's hypervisor, we've contributed over 20K lines circa 2010 to the Linux kernel. And as you can see, there's a continuous momentum of our involvement in the open source community to demonstrate our commitment, to customers that, we care about this space, we care about making sure their workloads run really well on our public cloud infrastructure. The last one that I would highlight, the last couple is pretty noteworthy. In 2014, fall of 2014, we made our first OpenJDK contribution. We also open sourced the .NET Core, which was a significant moment in our software history. And just a few weeks back, we announced the first fully managed Azure hosted service that runs on Ubuntu Linux virtual machine. So as you can see, we've had a long history. We understand the needs of the customers in this space, and we want to make sure that we continue to provide and meet customers' requirements in this space. All right. The last thing that I would leave with you in terms of our commitment, just to kind of demonstrate that this is not just me saying that we are committed. I have a couple of data points in the slide. This is our CEO Satya Nadella talking at a cloud event on October 20th, and I have the link here that you can directly find. he openly professed that we love Linux and we want to be able to kind of make sure that Microsoft is able to kind of support any customer workload running on Linux and open source. And I'm also referring to a recent article from news.com talking about our contributions there. And the key data point that was shared, this was our CEO that shared this data point. Today, 1 out of every 5 VMs in Azure runs on Linux, and you can see that there is a strong customer proof point here. These are customers running production workloads, development test workloads of various sizes and various scales on Azure. So this is not a start. We are already doing this, and we would love to kind of get more feedback on how Azure can better support these workloads. All right, so let's get started. So in terms of what does Azure have today? And if you're saying, hey, I want to take Azure for a spin, I haven't used Azure, or if you're already using Azure, how do you get started? I think the most simplest way to kind of get started for Linux and open source workloads is through virtual machines, which is our compute service. The key components that are required to support your onboarding of Linux and Azure workloads is an important reference point. So when you think about support for Linux in Azure, there are 3 components that you want to make sure these core components are in place. So you have a really good experience running Linux and open source workloads on Azure virtual machines. The first thing is what we call as the Azure command line interface. This is the node-based implementation of our service management REST API for creating, deleting virtual machines, for management of virtual machines. So that is the first component, and I'll quickly show you a demo of what that is. It's very simple to install. It's a Node.js package that is supported in all popular Linux distributions. You can install it on Windows. You can install it on Mac. It's a cross-platform CLI that is capable of creating and managing all Azure resources, not just virtual machines, but all Azure resources. And then obviously we have the portal experience that we have, and I'll show that to you as well. So if you choose to not use command line and you want to be able to go through our portal experience, you could do that as well. Both of them are actually calling the same REST APIs for managing Azure resources. So it's really just your choice on what you prefer. So that's the first component. The second component is what we call as Linux integration services. Azure, as a public cloud provider, we offer virtual machines. Most of our services, actually build on top of virtual machines. Both our platform as a service and software as a service, they all eventually build on top of, virtual machine infrastructure. So all the virtual machine infrastructure runs on Microsoft's hypervisor, which is Hyper-V. And one of the key things that you want to make sure is if you are running a Linux workload or an open source workload, that you are having the right version of what we call as the Linux integration services. Think of these as the drivers that you need in order to get a really ideal performance running on Azure virtual machines. And I'll talk about this in a bit more detail. And then the third component that is really critical to have a superior experience on Azure is what we call as the Linux agent. It's an Azure Linux agent. It's a really simple agent that is embedded in each of the virtual machines that enables some really basic functionality around networking, around ability to kind of bootstrap your virtual machines with some configuration information that you would like your Linux virtual machines to have, and so on and so forth. And again, we'll talk about it in a bit more detail here. So Azure command line interface, Linux integration services, and Azure Linux agent. These are kind of the 3 key components that you should know about and make sure that you have them configured properly. All right, so let's talk about Azure command line in a bit more detail. As I mentioned, it's a node-based implementation that wraps the Azure Service Management API. It is an open source implementation, so anybody can go look at the code, contribute to the code, file issues if you need to. It's an open source project. And it works on, like I said, Linux, Mac, or Windows. The steps to install is very simple. If you're a Linux user, this should be super simple for you. You install the Node.js modules, you install the package manager, and then you bring in the Azure CLI module. And in general, the organization of this command line interface is pretty simple. So we have Azure is the binary that you would execute, and then you can choose a topic, and a topic literally refers to the service that you want to manage, right? So, for example, VM refers to virtual machine, VM disk refers to our persistent storage-backed disks. Endpoint refers to some of the networking constructs and so on and so forth. So you choose the service that you want to manage, and then you have a set of actions which we call as verbs, right? You can start, restart, download, so on and so forth, and then you can have additional options for each of these actions, if you will. So to really quickly show you what this looks like, let me share my screen. And okay, and what you'll see here is a command prompt that I have. It's basically an Azure. So I've logged into one of my Linux boxes, and I've actually installed my command line interface here, the node-based implementation of command line interface. So I just type in Azure, and you'll see, some basic options around, here are the commands that, startup commands that you can use. I'm interested in Azure Virtual Machines, so I'm going to say Azure VM, and then I'm going to say help, and clear my screen. And you will see a bunch of startup options, right? So if I scroll my screen a little bit so you could get a view here. There we go. So I can do basic creation of virtual machines, listing the virtual machines that I have, showing the virtual machines that I already created with much more details, deleting the virtual machines. Very simple options that are all backed by our REST APIs right from the command line interface. So I already have, let me try and see if I can run a command. So if I want to list the virtual machines that I already have created, I would just do something like this, Azure VM list. As you can see what it is doing, it's executing the command, it's executing the REST API behind it. It already has information about my Azure subscription, which is authenticated by the command line interface, and it's pulling down information. So I have 3 virtual machines in this Azure subscription. So one is a Docker virtual machine, one is a demo virtual machine, and another is my dev test virtual machine. And you can see it has some basic useful information, which location this virtual machine is located, what is the DNS name, so I can directly hit that virtual machine, and then the IP address. And you'll notice that the first virtual machine that I have doesn't have the IP allocated. And that is because I have stopped that virtual machine, and so I don't have to pay for it. But you could essentially start the virtual machine right from the command line, do basic operations on top of that. All right, so that's your virtual machine command line interface. Again, like I said, the node-based command line interface is capable of managing any of the Azure services. So let me go back to the slides here. So that's the command line interface. This is the first core component. So if I go to the next core component, this is the Azure Linux agent. As I mentioned, this is a very thin agent that runs on all virtual machines. We have a version of the agent that runs on Windows virtual machines as well. And in this case, this is the agent that runs on the Linux virtual machines. The primary purpose of this virtual machine is to make sure that it manages the communication between the software that you happen to run on your Linux virtual machine and our Fabric. And Fabric is what we refer to as the software layer that is managing thousands and thousands of virtual machines that runs on Azure, right? So, and the primary content of the communication is around virtual machine health. If the virtual machine for some reason is unhealthy, meaning like say for example you can connect to a virtual machine, the virtual machine is in a crash state for whatever reason, our Fabric would be able to kind of recover that virtual machine through some heartbeat signal. So think of it as basic health channel communication. In addition, the Linux agent also does a bunch of additional functionality within the virtual machine. Mainly around provisioning. If you want to bootstrap your virtual machine with certain files, say you want to run a startup script at the beginning of the virtual machine creation, using say for example Cloud Init, or you have some user data or custom data that you want to pass in, Linux agent is responsible for doing all those functionality. It also does very basic, network management, some kernel support functions like, serial console, and debugging functionality, and so on and so forth. We also have what we call as virtual machine extensions. This is a very differentiating functionality for Azure, where if you want to be able to run a specific arbitrary set of, say, shell scripts, like a bash script or a Perl script or whatever script that you want to run, and you want to run it at any point in the lifetime of the virtual machine. Now we have this mechanism called extensions that would support, extending the functionality of your Linux virtual machine at any point in the lifetime of the virtual machine. So again, Linux agent is responsible for implementing that ecosystem. We have a partner marketplace that supports a variety of ecosystems, starting from things like configuration management software like Chef to just things around security management and so on and so forth. So we'll talk about it in a bit more detail. The code for the Linux agent again is open source. You should be able to go find it in GitHub, and it's like I said, it's just an implementation that is open. Again, you can file issues there. We take a look at it pretty closely, but it is a key component that is important for you to make sure that you have it installed. If you're bringing your own image as opposed to using an image from Azure Marketplace, you would want to make sure that the Azure Linux agent is installed in it. So you can go directly to GitHub, download the binaries, and install it. So, and this is the directory that you would install, the user/sbin, the Windows, the Azure agent, if you will. So to quickly show you what that command looks like, I have a virtual machine, the same virtual machine that I showed, that happens to have the Azure Linux agent installed. And I'll quickly show this. Share my screen here. I type in the agent, and I can see that it shows up a bunch of commands here. And what I can do is I can demo a simple command. So here in this case I want to get a serial console output at this point. So I'm going to say, oops. So I am obviously running without a super user access. So what I'm going to do is I'll do a sudo, and you'll see the command executed fine. And what I'll do. Okay, so I'm going to run this command again. I ran that. As I mentioned, you need this, but the log that I wanted to kind of show you is right here. So oops. And this is the log. So basically, this tracks all activity that is happening in the virtual machine. So you could see that, when the virtual machine booted, I see some errors here. So I should be able to kind of go debug, what's going on right there. So it'll have the version of the virtual machine, what specific, distribution that I'm running, and so on and so forth. So basic debugging information that you can use to kind of troubleshoot your virtual machine. All right. So going back to these slides here. So that's the Linux agent. And then the third component that you want to make sure that you have installed in your virtual machine is the Linux integration services. And the Linux integration services primarily use drivers and enlightenments to make sure that your Linux workload running on a virtual machine is taking advantage of all the latest and greatest advancements that we do in our hypervisor. Now, if you pick the most popular distributions, things like distributions like Canonical, especially if you start from the images that are available, for example, Canonical images or OpenLogic images, or any of the endorsed distributions that we support from our Azure Marketplace, the Linux integration services is already installed. In fact, most popular Linux distributions already have Linux integration services automatically installed as part of the kernel. These are changes that are made to the Linux kernel upstream already. But if you're bringing your own virtual machine with a specific distribution that you use on premises, you want to make sure that it is using the right version of the the Linux integration services. And you definitely want to check that, because if you care about applications like MySQL or Postgres, database applications running within these virtual machines that care about getting the most ideal performance. You want the latest and greatest drivers. Again, you can find more information in this GitHub location. We have different versions of Linux integration services available there, and you can find the different functionality that we enable in each version. All right, so these are the core components. Now, how do you get started? So there are two paths, obviously, right? So you can bring your own Linux image. We talked about it a little bit. And the steps are pretty simple. You have your own virtual machine running on premises, on whatever hypervisor that you use today. The first thing that you want to do is capture that virtual machine and create a VHD image. A VHD stands for virtual hard drive or a hard disk. And this is the format that the Hyper-V, which is the Microsoft's hypervisor, recognizes. So the first step is to really create a VHD of your Linux virtual machine that you're running on premises. And it's very simple. We have documented a set of steps. The idea is to be able to create that VHD image. But before you create, make sure that you're using VHD and not VHDX, because currently VHDX is not supported. And you also want to make sure that you're using the standard partition for OS disks. A lot of customers I know use LVM for OS disks, but at this time we don't support LVM use for OS disks, so you have to use the standard partition. And you want to make sure, this is the point that I made earlier, you want to make sure that you have the right versions of the Linux integration services, and you're installing the Azure Linux agent to make sure you have the support that is needed when you bring that virtual machine to Azure. And you can use the Azure Linux agent to actually configure the swap partition. Azure virtual machines have an ephemeral temporary drive, and you can use that temporary drive to kind of use as a swap partition for your Linux operating system. And we have a lot of documentation in Azure.com for specific distribution instructions, right? So if you're using CentOS, or if you're using Ubuntu, a particular version of Ubuntu, we have specific instructions on where to grab the packages for the Azure Linux agent and what configurations you need to do. So once you do the first step, which is creating a VHD image, you then upload the VHD to Azure. It's a simple command. If you're using the Azure command line interface, all you have to do is say Azure VM image create. If you're using, if you're a enterprise that happens to use both Windows and Linux, and you use PowerShell and you're comfortable with PowerShell, we have equivalent commands in PowerShell as well. Again, you can do the same either from the Node.js based CLI or PowerShell. All right. So the second path is starting from an image in marketplace. So Azure today endorses a set of Linux distributions, and we also work with these distribution vendors to make sure that their images are available in our Azure marketplace. So a customer can go to Azure marketplace, and I'll show a quick demo of this, and you can just pick the distribution that you want, pick the version of the distribution, and just get going. In general, all these images are published and maintained and supported by these distribution partners like Canonical and OpenLogic and so on and so forth. SUSE is one of our other distribution vendors, and you can see, these are the supported ones. SUSE, CoreOS. I have a table in my next slide. And we have two categories of these, virtual machine images. One is called standard images. Standard images are where the customers need to contact and work with the Linux vendor or the partner to get the Linux support. But any Azure-related platform issues would be, supported by Microsoft. So if you have a support agreement or a support contract with Microsoft, we'd be able to troubleshoot Azure-related platform issues. We also have premium images. Today, this is SUSE, SLES 11 SP3. This actually is, it's a different support experience, an elevated support experience, where as long as you have the support contract with Microsoft, that should be enough for you to engage with Microsoft. And if the issue turns out to be specifically on the distribution, the OS distribution, Microsoft would contact, SUSE in this case on your behalf, right? So you would be able to get updates, patches, and support 24/7 through web, email, chat, and phone. So again, two categories, and you want to be, when you're thinking about moving your applications or creating your Linux-based workload on Azure, you want to look at these two choices and make sure that you are getting what you're looking for. And this table in the slide that I'm showing gives you a high-level summary. Again, all of this is documented. I even put a link there. These are the the endorsed distributions in Azure today. So we have the canonical Ubuntu, the different versions that we support, the OpenLogic CentOS distributions, CoreOS, which is a container-optimized distribution, Oracle Linux. This is supported Linux distributions, SUSE Linux Enterprise, as I mentioned, our premium image for SUSE Linux Enterprise, and then of course the OpenSUSE itself. All right. There is another way to start from a gallery image. So Azure today supports two models. One is what I talked about, the Azure Marketplace. We also have a community-supported marketplace, if you will, a community-supported VM image marketplace called VM Depot. And this is basically where anyone in the community, including you, can actually contribute your favorite Linux distribution with specific application software on an open source model, right? So this is again a website that Microsoft OpenTech, which is a subsidiary of Microsoft, that maintains, and you have thousands of Linux images with various applications available here. So to quickly show you what that experience looks like, let me share my screen again. And first one, I want to walk you through our portal experience in terms of how you can get started with a Linux image right from our marketplace. So the first thing that you would do is you would log into portal.azure.com. This is the IP, the DNS address for you to kind of access. Once you log in, you would see the screen, and you should be able to just click on Marketplace here, and you would see our marketplace loading up here. And as you can see, we have various image offerings that are available. We have a Docker on Ubuntu server. We have some of the newer offerings that we have, a Cloudera Enterprise, Oracle Database, CoreOS. So one thing I wanted to know is, I wanted to go browse the set of Linux virtual machines here. So what I would do is I would click on virtual machines, and then I would get a specific blurb on the Linux-based virtual machines, which I have a separate icon role here. So right here, you can see some of our endorsed distributions is showing up here. So if I wanted a CoreOS or I want a SUSE Linux enterprise server, say if I choose this, I click on that, and I get some nice information on what this distribution is about, some legal terms that I would have to accept, and then I would say accept that, and I do a create, and then I'll get another. Let me see if I can move my screen. Another blade where I get some basic information that I would need to enter around, what is the name of the virtual machine that I want to put, what ports do I want to open, do you want the SSH key, username, password, and so on and so forth. So you can see that the portal is now loaded. So what I would do is, just add in a test, Linux OS. I put a username. I can use a public key or a password option, and I can basically do basic configuration. All the things that you are able to do from your command line interface, you could do this from on-premises, from a portal point of view as well, from a user, a graphical user interface point of view. So that's how you start creating an image from a portal, from our portal. Now you could do this also from VM Depot, which I mentioned is our community-based portal, and as you can go see here, you have over 1,000 images here. So you can literally just search for, say for example, if I am searching for, let's say, MySQL, and I can go search in MySQL. I'll get some matches on MySQL images that are available, and it will essentially show up here. And then the interesting thing here is, if I want to create a virtual machine here, I can click on what I call as the deployment script, and what it allows me to do is actually creates the script, for me. So say, for example, I'm deploying this virtual machine. This happens to be a Tomcat virtual machine running on Ubuntu. And I say I want to deploy this in East Asia. It actually pre-creates the CLI command for me, and all I have to do is just fill in the blanks, use the DNS name that I want, use the username password I want, or the SSH key I want, and just that's it. I can just copy paste it, go to my command line interface, and literally just cut and paste the command, and I can create the virtual machine literally in like few seconds. You can also, through our marketplace, if I go back to my portal, be able to deploy images that are in our community, the VM Depot community, right from the portal as well. And you will see a subset of images from our community that are that are running on endorsed Linux distributions on Azure. So not all the VM Depot images, but the subset of them that are built on our endorsed Linux distributions. For example, the list that I showed, right? Again, same exact thing. Instead of doing through a CLI experience, you would go through a graphical user interface experience. So you read the command, you say create. We end up creating a UI experience for you with common information, host name, username, same set of things, right? All right. So that's the portal experience and how you can get started. Now, if I go back to my slides, we talked about this. The other path for you to start is, say you are saying, I already have a virtual machine running on premises. It's running on Hyper-V, it's running on VMware, or maybe I'm already having a virtual machine, a Linux virtual machine running in, Amazon, for example. And I want to be able to kind of migrate that to Azure. Now, you could do that. We announced a new preview service called Migration Accelerator that allows you to do exactly that. You can move even physical virtual machines. If your source is the physical virtual machine, you're running it on, a physical machine running Linux on premises or anywhere else. You should be able to point to that and say move it to a virtual machine on Azure. And it's a very simple tool, very intuitive, that allows you to do simple migration. It's currently in preview, but you're able to support the following Linux distributions: CentOS 6.4 and 6.5, and Oracle Linux. And you're able to, the technology allows you to enable replication that can set up this relationship between your source virtual machine and your target virtual machine running on Linux. And at some point, you will be able to kind of migrate your entire contents of your virtual machines into Azure, and you can go from there. The Linux support, as I mentioned, was announced on January 13th, pretty recently. And there is a blog link here where you can find more information about how to get started with this tool. All right. Now, I wanted to kind of briefly touch on Azure Resource Manager. Now, Azure Resource Manager is essentially the new template-based language from Azure that allows you to create multiple virtual machines. So you can create, for example, a MySQL workload with a website front end, maybe Nginx, and a bunch of virtual machines all together expressed in a single JSON file. And this template then would be, executed by Azure, the Azure Resource Manager component in Azure, that ensures that it's idempotent. It can perform orchestration in terms of deployment and rollback, and it's essentially a source code. Right? It's essentially configuration as a code mentality that you can just check in and actually keep track of any changes. So it allows you to simplify your deployment processes instead of dealing with each of these resources one by one. And we have several examples of it already in our marketplace. Again, I talked about Cloudera Enterprise. It actually creates 6 D14 virtual machines running on Linux with Cloudera software running on it. So within the same UI experience, you would be able to, with few clicks, create a whole deployment, a Cloudera deployment. And same example for DataStax. Again, here we have 8 virtual machines. These are your, the nodes that are actually doing the work, and you also have a front-end node, if you will, that actually orchestrates the work. So all within, basically these are JSON files, essentially are templates that you have composed, an application topology, and Azure Resource Manager is able to implement for you. So this is, if you're interested in creating an entire application topology. I talked about VM extensions. So VM extensions is something that the agent, the Azure Linux agent, supports today, and it's a pretty simple capability, but yet very powerful. It is able to extend the functionality within the VM by enabling different partner, IP infrastructure to be injected into the virtual machine at any point in the lifetime of the virtual machine. So it's primarily focused on VM management and VM customization today, virtual machine customization today. And, the way it works is you basically have an agent. I'm trying to see if I can get the animation working. It doesn't seem to work. So anyway, the agent, what it does is it accesses a secure repository where our partners who are participating in the marketplace, and I have a few examples here, Chef and Docker, they work with us to kind of publish a package there that allows the agent to access that package and actually install it inside the virtual machine. And once it's installed in the virtual machine, you are able to directly access. For example, if you installed Chef, you directly have a Chef client installed there, and you can directly start using the Chef recipes into your Linux virtual machine on Azure. Same thing for Docker. If you install the Docker extension, it actually installs the Docker daemon or the Docker engine into the virtual machine, and then you're able to use your command line to directly talk to the Docker engine and pull down your container packages. So again, it's an ecosystem that is rapidly expanding in Azure. And if you want to be able to use Chef for Docker, it's a very simple command from the Node.js-based command line interface. You just say Azure VM, I want this extension. You call it the name of the extension and the publisher, and then essentially it's installed in the virtual machine. So it allows you to kind of get the best of PaaS and a platform as a service-like capabilities, but keeping full control of the virtual machine for you. So as you can see, we have already a few very popular Linux extensions that are available. Custom script for extension is one of those popular extensions where you can essentially author scripts, and it could be in Ruby, Python, Bash, Perl. Pick your choice. You upload them to an Azure storage account, or you can put it on a GitHub location, and then you essentially just install this extension and say, here is where my script is. And the VM that you are installing this extension would be able to run the script that you're pointing to, basically download it, bring it to the virtual machine, and run it, and report back the status. It's a very powerful functionality because literally this script can do anything that you can do from command line, right? You can install a MySQL, you can install a bunch of packages, you can patch the virtual machine, anything that can be done through scripting. It can be done through the custom script Linux extension. We have some documentation and blog on it. I would encourage you to take a look at it. It's pretty powerful functionality. We also have other Linux extensions. I don't want to go into detail, but I want to touch on some of these, really powerful extensions. So VMAccess extension allows you to, without opening any ports, if you forgot your SSH key or if you forgot your password, to reset your password. Very, very handy. A lot of customers who, get into this situation and they're not able to kind of access their virtual machine, they can just deploy these extensions and then reset their SSH key or password. OS patching. If you're interested in kind of if you're interested in creating application software and not worrying about patching of your Linux virtual machine, we have an extension that allows you to automatically and on a scheduled basis update the Linux virtual machine, right? Bring down the security patches on a specific day or a specific time of the day, and you can actually coordinate across multiple virtual machines. So you can actually have a large service running on Linux virtual machines on Azure and actually have an OS patching extension coordinate the update schedule for you and coordinate in a way that your application doesn't go down. Not all virtual machines are updated at the same time. We have portal integration. You can do this, configure this extension through portal as well. I talked about Chef. We support Chef on Linux virtual machines today for CentOS and Ubuntu. The entire Chef ecosystem would be available as soon as you install the Chef ecosystem. You can use Knife, you can use Chef recipes and cookbooks on your Azure virtual machines. We also support the Docker extension. Docker obviously is a very popular container-based application ecosystem that is rapidly evolving. It works today on Azure Virtual Machine. We have a Docker extension. It's very simple to install. All you have to say is Azure VM Docker create. We actually create a virtual machine with the Docker daemon pre-installed. Single command, you are set to go, right, within a few minutes. We have started doing the Azure Marketplace integration with Docker Hub. You could see, our first Docker on Ubuntu server image that is available, and we'll have few more. We've publicly talked about our commitment with Docker to enable deeper integration in our Marketplace. We've been working on Docker Machine, Docker Compose, and Docker Swarm support. All these three were announced in DockerCon last year, so you can expect that we'd be supporting all three of these tool sets for Azure. And then we also announced publicly that Docker API will be the primary management interface for Windows Server containers, which we said we are working on for our next version of Windows Server. So What that means is Docker becomes the primary API for managing Windows and Linux containers. For customers and enterprises who happen to have applications that are spanning Windows and Linux ecosystems, you have an opportunity to kind of have a consistent API management interface. All right. So there are, if you want to summarize how to get started, there are many ways to get started. You can bring your own image. You would have to have your own license mobility. If you're using Oracle or IBM images, for instance, you can start from an image in the marketplace. You can create a single VM, or you can create multiple VMs in one go. You want to make sure that the distributions that you're using are endorsed. When you start from Marketplace, these are all available in Marketplace. I talked about that. You can start from a community image in the VM Depot. It's an OSS model, open source model in terms of licensing. It's basically, it's a do-it-yourself model, if you will. You can use VM extensions that I talked about to add, either first-party extensions that Microsoft provides or third-party extensions like Chef into your virtual machine and extend the functionality. And then, like I mentioned with Docker, you can also use Docker to bring down containerized applications on Azure on Linux virtual machines today. So this is the summary. Now, if I were to think about, okay, I got the operating systems, now what is beyond that? Obviously, when you talk about open source, it's much more beyond just your operating system. So what I'm showing you here in this slide is the entire diversity of the ecosystem that we support, right? So if you look at the slide, we have the MS integrated set of ecosystems that we support today, and what the ecosystem is providing. So, right, the MS integrated column talks about where we've done specific work to, integrate with Azure deeply. The ecosystem provided one is where the open source community is doing the work to make the Azure as a supported cloud, public cloud provider. So when you think about the languages, development tools, and application containers, all the way from Docker, Visual Studio Online, we support, any language stack, whether it's PHP, Python, Node, Java, Ruby. In terms of content management systems, we support, WordPress, Joomla, Drupal. You can see, our diversity, our commitment to diversity in terms of the full stack, full application stack is demonstrated here. And if there is something that is not available, obviously this slide is a representation, not the full list. But if there is something that is missing and the customers are asking for it, we are always open to, working with them to provide that support. So let's take a quick look at Java. I know Java is a very important ecosystem, Java on Linux, Java on Windows. We have pretty comprehensive support on all our services, infrastructure as a service, platform as a service, or the platform as a service websites. If it's infrastructure as a service, you have Windows or Linux VMs to, support Java. You can download the Oracle JDK, the Azure JDK. These configures are pre-configured. If it's a platform as a service, we actually provide, through our Java SDK support, being able to use Eclipse and IntelliJ to program your Java application and deploy on our platform as a service. We also have Jenkins and Hudson plugins for using our platform as a service services, things like Azure Storage. And if you're using Azure Websites as your website solution, we support, the Java as a runtime. We also have a Java SDK for our Azure websites. And our other portfolios like DocumentDB and SQLDB, we have support for Java as the software development platform. LAMP, again a very popular ecosystem, especially customers lifting and shifting existing applications from on-premises. You can deploy a pre-built image that is available in Azure Marketplace or VM Depot, or you can install it on your own. You can bring your own image. I have a snapshot of what is available in the marketplace today. As you can see, there is multiple options. In this case, it's all published through Bitnami. But you should be able to just click, as I showed earlier in the portal, and just quickly have a LAMP stack installed on your virtual machine. And just to finish the data platform equivalent, we also have the NoSQL solutions available. I talked about the data stacks and Cloudera. But if you want a platform as a solution, we also support Azure HT Insight now on Linux with support for some of the most popular open source packages, right? HBase, Mahout, Storm, and Hive. So again, in terms of the diversity, anything that you're using, we want to be able to support on the Azure public cloud platform. We also have a really vibrant, growing marketplace of partners. You can see all their logos here. This is obviously not the full list, but there is there's over there's hundreds, if not thousands, of solutions already in our marketplace, and we are expanding on a weekly basis. Solutions ranging from configuration management, security management, specific vertical focused solutions, financial software, monitoring software, across the broad spectrum of software that is available in the marketplace. As I mentioned, you can just go to the portal, browse through our gallery of marketplace, and be able to just click and deploy it into your virtual machines. And I wanted to kind of quickly touch on case studies and then open up for Q&A. So, like I mentioned, customers are already running production workloads. As I mentioned earlier, 1 out of every 5 VMs in Azure today runs Linux, an open source solution on Azure. We have several big customers who are, running production style workloads on Azure. Here are some examples. We have case studies available for each one of them in terms of what they've done and how they've, successfully be able to run a production workload, taking advantage of Azure's services, both infrastructure as a service and platform as a services. Virginia Tech is one. They obviously are running. They're basically a DNA sequencing application. They're significantly dependent on their Linux infrastructure that's running on Azure. Another example was the British the sports club. You can see their code. Obviously they were thinking, Linux on Azure would be tough, but obviously they were pleased to see that it wasn't the case. And the last case study that I would show is from CloudMunch. Again, they use JavaScript and Ajax on Linux platform, and they're able to take advantage of the Azure support easily today. I have some example references here. I wanted to kind of quickly show you our documentation page as well. If I share my screen here, we have a landing page that we are working on for all Linux and open source content in terms of tutorials, in terms of how to get started. It's very simple. It's Microsoft.com articles. You would actually find this from the right from the virtual machine documentation. It has a really good collection of getting started content, distro-specific content if you're using Ubuntu or Debian or CentOS. Really a wealth of information here. So I would encourage you to take a look at this. And last but not the least, give us a try. If you're running Linux workloads, on premises and you want to try on Azure, take a look at Azure. Take a look at the support that we have. If you have any issues, obviously, contact us. We would love to kind of work with you. John?
Great, thanks, Manad. So I want to just encourage everyone to submit any questions that you have now. We have about 3 or 4 minutes for Q&A. And it looks like we've already got a couple questions in here from the audience, so we'll go ahead and jump in. So first question from Dan, is there any way to run a GUI on the Azure Linux server remotely?
Yeah, that's a great question. Yes, you can. At the end of the day, it's just a Linux virtual machine running on a hypervisor on a public cloud platform. So if you're using, any of the popular, like remote tunneling software, personally I use something like a VNC client that you can use to kind of remote into your virtual machine, and you can actually have a Windows manager that shows up the UI. There's obviously a variety of choices. All of those choices should work. There's no difference than a virtual machine running on premises. We actually have a documentation. I don't have it handy, but if you search for being able to connect to a virtual machine and actually use it as from a graphical user interface, you'd find a wealth of information. Our landing page also will have information on how to do that, and you can the landing page that I showed, so you could use that to find that information.
Great, thanks.
Okay.
And it looks like we've got a couple questions here, kind of similarly themed, just around any common challenges, I guess, that folks should have top of mind. Any pitfalls when folks are first moving open source workloads to the cloud that you'd want to flag for people.
Yeah, so I think one of the things that you want to be aware of, as I mentioned, the key thing to take care of when you're considering moving your application to Azure from a Linux and open source point of view, make sure the core components are correctly configured, right? Specifically the Linux integration services and the Azure Linux agent. That's where we typically see, customers hitting some, startup issues, right? So making sure that those core components are configured correctly is critical. And then I think, depending on the workload that you're running within the virtual machine, say if I'm running a MySQL workload or a database workload, Postgres, MariaDB, whatever that is, obviously make sure that you consult our documentation in terms of configuring the virtual machine for the ideal storage performance. Our storage for virtual machines is backed by Azure Storage, and we have extensive documentation on how to, for example, if you want to run MySQL on Linux virtual machine in Azure, we have very targeted documentation on how to RAID your disks, how to kind of configure the caches properly, so you can get the right amount of IOPS and throughput and latency. So I would say storage is another area where storage performance configuration is another area where I think you should kind of pay attention. And then the last one that I would say is networking. A lot of real-world applications span more than one virtual machine, and this means essentially creating a set of virtual machines and maybe platform as a services, and then wire them up in a way that it is secure, right? Enterprises like to create applications that are not that does not have access to the outbound internet, right? So we have a lot of solutions for doing that. We have ExpressRoute, which is our secure connectivity solution. You can have site-to-site VPN connectivity. In all these cases, you want to make sure that your networking configuration is done properly. And again, our documentation have a lot of get started and how to step-by-step tutorials, because configuring them correctly would make sure that you're getting the optimal performance, and at the same time you're not compromising on your security goals.
Great. Well, thank you. It looks like we're just about at the top of the hour, so you just want to say thanks again to everyone for attending, and Madhan, a big thanks to you for leading today's session. Just for those in the audience, please do give us your feedback on the webinar today, and any topics you'd like to see us cover in the future. And also, just want to note that we'll be sending along a recording of this presentation via email shortly. So I hope you all have a good day.